Hello, all of you. We're moving on neurons part 2 still. And now we're going to talk about the differences between these potentials. It could be action potentials or graded potentials. So let me show you this. Let's start with the one down below. Let's start with the action potential here. And we'll start here. And we've talked about action potentials and how they initiate in the axon hillock, and they will transmit current all the way down the axon to the very end of that axon. That's an action potential. It never loses intensity. It will, if it's triggered in the axon hillock, it will travel to the very end of that axon. Now we're going to compare it to a graded potential. So my little stick guys here, this is the one that's active, that's going to go to the very end, and this one could possibly lose intensity. So it could start an action potential and then not really get to the other end of the axon. Let's look at that. So why? Why is this happening? Why does a graded potential actually lose intensity? Well, what happens is that there's a current leak. The membrane in the cell body isn't well insulated. And so you could have leaky channels. So now we're talking still about, this is my axon. And in the axon here, incoming signals are coming in through the dendrites, and they still have to come into the cell body before going all the way down the axon. Now, if, however, you have some leaky area here, because remember, this is not myelinated, and this is insulated, and this is not. So if the cell body is not, then you could have some leakage of ions. This is not well insulated, and just like this leaky hose here, you could have potassium ions that are leaking out and not allowing for that action potential to actually fulfill itself, essentially. There's also cytoplasmatic resistance. So think of how tiny the axon is and how much more mass there is to the cell body. So this mass here is going to provide resistance to the flow of electricity. So as electricity might come in through here, maybe it'll come and actually not reach the axon hillock. If it doesn't reach the axon hillock, then you have no action potential coming to the other end. So always when we're talking about graded potentials, we're talking about them here as they come into the soma or the cell body. This diagram again of my graded potential here is losing energy. I would have an axon from a different cell, and it's connecting to the cell body here of cell number 2. Presynaptic, postsynaptic. So this cell number 2 here is what we're looking at, and you have, sodium channel opens, it depolarizes, and it depolarizes a neighboring channel, and then it depolarizes the neighboring channel. But as it goes moving, there's leakage. This is my mouse. There's leakage, and the big arrow, which is showing that current and those opening of those channels, is getting meager and smaller and smaller and smaller. So what if it never reaches the axon hillock? So think of this, in terms of a very slight stimulus. Let's say there's a tiny bit of light coming into your eye, not enough to actually form an image. It's kind of like a graded potential that dissipates here and never quite makes it so that you can't really form an image in the eye. What about a sound that's coming in here that is so faint that you those channels are not all opening because you don't have a whole lot of intensity and you lose it and you never transmit that signal. So I'm telling you that in this slide, incoming signals may be weak, but they may be strong. And if it's strong, we might have lots of signals coming in, and then they're going to make it to the axon hillock, and that's going to depolarize the axon. But alternatively, It might just be one little signal coming in here that loses strength, it loses current, and it never makes it to the axon hillock. Remember, no myelin sheath here. Yes, myelin sheath on the axon. In an experiment, then, you could look at what would be one of those signals that was of very low intensity. The example of the light coming into the eye, a mosquito landing on you that you don't feel. What would that be like? So you'd have a stimulus coming in that was pretty strong, but it got weaker and weaker and weaker. So if we could measure and get my voltmeter and measure it up here, we'd see, oh, look, it's above threshold. There's quite a bit of change in membrane permeability. And then I measure halfway and I see that, oh yeah, there's still enough. Look, it just reached threshold and it would depolarize. But remember, the trigger zone or the axon hillock is a very important location. And if I measure right before that region, I would see that that little bit of depolarization that's happening is not sufficient because it has not reached the -55 threshold. So we say that that graded potential is below threshold, and there will be no action potential happening right there. So my little stick guy is just relaxed here. Nothing's happening. But there was a stimulus. It just wasn't strong enough for it actually to be propagated. What would an above threshold graded potential look like? Again, we would measure where it came in, around the middle, and around the axon hillock. Where it came in seems pretty high. I have an AP firing. In the middle, it seems quite high. It's above threshold. I have an AP, and it would be firing. And then I measure it right by the axon hillock, and I see again that that has truly crossed the threshold. And that graded potential then has become an action potential as it travels down the axon. So it's an above threshold graded potential that becomes an action potential. Now, one neuron really is influenced by many synapses. You know, we look at one like this, but really you could have these many axons, axon terminals of the presynaptic neuron, of these. You have hundreds of these that are all feeding in to this one cell body here, not just two little spots here, but many spots here. And on top of that, there'll be some glial cells. If you remember from anatomy, they're taking care of these guys, and dendrites. So you have so many signals coming into that one. So you could have many that are stimulatory, and even though lots of them are very faint signals, they would together have enough depolarization to reach the axon hillock and create an action potential. How many synapses are normal? What's a normal number of synapses that you could possibly have? Well, moderate number is about 10,000. Can you start imagining that? And then some cells in the brain have up to 150,000. So complicated to study this. I have a really good video for you where they've tried to actually map out those individual neurons and how it would look like in a brain with these 3D scans, and each one of these would be a neuron and how they connect to each other. So be sure to check that out in my list of YouTube videos, and we're going to stop this mini lecture here.